Hello everyone, welcome to the fifth lecture video for the Math 22 series MBAN 109 in preparation for LA1. So we're going to be discussing today about improper integral. So basically, may mga methods tayo na nadagdagan dito na hindi karaniwang ginagamit sa mga integrals na sinasolve natin in the previous lessons as well as no Math 21. So let's proceed. So there are two types of definitions. There's the first one. If f of x is continuous on AB, where A sa A discontinuous siya, and limit as x approaches A from the right, f of x is equal to positive negative infinity, or f of x is continuous on negative infinity B, then yung definite integral na ito from A to B, f of x dx, is equals sa limit as t approaches A from the right ng same integral. So, bale, napalitan lang ng A to T. And kaya A from the right kasi this is the lower boundary ng ating definite integral. Then, kapag naman yung sa negative infinity, we replace A to negative infinity. Then, same process, substitute T, tapos T approaches negative infinity naman dito. On the other hand, if f of x is continuous on AB, this time, sabi naman siya discontinuous, and you know na positive negative infinity from B to the left, or f of x continues on A positive infinity, then this time yung T naman nasa taas kasi upper bound yung B, and kaya din siya from the left yung kinukuha na limit as T approaches B from the left. Or replace B with positive infinity, then same substitution of T positive infinity. So take note na if the limit exists, the integral is convergent. Otherwise, ano siya? Divergent siya. So may expanded definition tayo tungkol dito. So if f of x has an infinite discontinuity at C, where A is less than C, less than B, then we can split this integral into two improper integrals. So pansin mo, sa discontinuous siya sa C, so need natin muna hihiwalay since we need to solve first yung limits ng bawat isang parts na discontinuous siya. So this can be also applied kung kunwari may D, tapos nasa loob ng A and B din yung D na yan. So maghihiwalay ulit to D, C, tapos puro continuous dapat yung mga endpoints para magamit natin itong mga definitions na nandito. So likewise, dito naman, pag continuous naman si f of x sa all real numbers and c is in the set of all real numbers, then yung integral from negative infinity to positive infinity, f of x dx is equal to sa dalawang integral na ito. This time, instead of discontinuous si c, dito naman continuous naman si c sa part na ito. So, take note na yung negative infinity at saka positive infinity naman yung laman nito. And also, if at least one of the improper integral is on the right is divergent, so yung mga nandito sa kanan ng equation, then the integral as a whole, yung nasa kaliwa, ay divergent. Otherwise, they are convergent. So kaya tayo gumagamit ng limits dito sa preview, sa part na ito, kasi we cannot just substitute positive negative infinity to an integral. Especially kapag nag-evaluate tayo sa definite integral. Since we know na infinity is just a concept, not a number. Okay? So before we go to the problems, let us recall the use substitution, which will be useful in most of our problems for today. So use substitution, or also known as integration by substitution, is one of the most common methods or techniques sa integration. So we have an example here. Integral nitong 6x squared cosine 2x cubed dx. So we get u equals 2x cubed and du equals 6x squared dx. So pag sinabstitute natin yung mga values, mawawala itong 6x squared at saka dx. So yung matitira is itong cos 2x cubed na magiging u. So integrate ng cos u du, so sin u, so magiging sin 2x plus c. So do not forget kapag kapag may ganitong mga integral tayo, do not forget the plus c. Pero since we are using definite integrals naman, we don't have to worry about the plus c. So, chillax lang tayo ngayon sa, since puro definite integrals naman yung isosolve natin. Okay, so let's proceed with problem 1. Evaluate the integral from negative infinity to negative 2 of x all over quantity x squared minus 3 squared dx. So, kung gusto niyo munang isolve, you can pause the video. Pero kung gusto niyo ituloy, then just continue with the video. Okay, so let's proceed. So, notice na continuous siya sa negative infinity to negative 2. So, we just need to take the limit as t approaches negative infinity ng definite integral na ito. So, substitute lang t sa negative infinity dito sa part na to. Now, we use u sub dito. Let u equals x squared minus 3 and du equals 2x dx. So, since definite integral to, para mas madali na ang buhay natin, we just need to substitute na lang yung x natin to u para mas madali na yung pag-evaluate ng definite integral. So when x equals negative 2, u equals 1. And when x equals t, u equals t squared minus 3. So ano lang yan? T dito, kaya t squared minus 3. Okay, so next. So bale, magiging ganito na yung integral. So magiging ganito na limit as t approaches negative infinity ng integral from t squared minus 3 hanggang 1 ng 1 over 2u du squared du. So, bale, nag-shortcut na tayo since we know na the integral ng 1 over u squared du is equal to negative 1 over u plus c. Pero since definite integral to, we have the boundaries here. So, limit as t approaches negative infinity, yung constant is 1/2, kaya lumabas 1/2 times negative 1 over u. Kaya negative 1 over 2u evaluated from t squared minus 3 hanggang 1. So, bale, t limit as t approaches negative infinity. Now, negative 1 over 2 times 1 plus 1 over 2 times itong t squared minus 3. So, notice na kapag in-evaluate mo itong negative infinity dito, magiging infinity na itong babang equation. And since under yan ng 1, magiging 0 na itong equation na ito. So, bale, therefore, let's proceed. Magiging ganito na lang siya. Pwede mo nang i-isolate yung 1/2 since negative 1/2 since constant naman siya. And we evaluate this. And what, like kanina, equal to sa 0 since nasa baba yung infinity. So negative 1/2 plus 0 is negative 1/2. Therefore, yung integral na ito, equal siya sa negative 1/2. And since may value itong integral na to, this is convergent. Okay, so next, proceed to the next problem. Evaluate the integral of negative 2 to infinity, positive infinity rather, ng 1 over x plus 1 dx. Okay, so pause muna kung gusto nyo i-solve and continue sa video kung gusto mo makita yung solution. Okay, so let's proceed with the solution. So this function has an infinite discontinuity when x equals 1. Negative 1 pala. This is not negative 1, but positive 1. So, bali nakasplit siya into 3 parts. So, una, split in terms of sa negative 1, ay sa positive 1, which is itong 1, negative 2, tsaka positive infinity, at tsaka 1. Then, we split it again into 2 kasi nga, discontinue siya sa dalawa. So, 2 at tsaka 2 dito sa part na to. We can get a constant. Yung importante naman dito is kung convergent ba siya or divergent. Total magkakancel naman to eventually in the long run. Okay, so we split this into 3 integrals. Tapos we take the limit ng mga parts na kung saan siya discontinuous or equal sa positive negative infinity. So t approaches positive infinity, v approaches 1 from the right, tsaka m approaches 1 from the left ng mga definite integrals na to. Then afterwards, we now evaluate the integrals. So shortcut natin. So integral ng 1 over x minus 1 dx is equal to ln ng absolute value x minus 1 plus c. Pero since definite integral na to, we evaluate from the boundaries. So, andun pa rin yung limit since hindi pa siya nasosolve. Then, we evaluate muna in terms of definite integral or fundamental theorem calculus number 2. So, ito, makikita nyo to. Then, notice na kung positive infinity to, infinity na to. Then, kung notice na 1 from the right, yung graph ng ln is actually ganyan. ln ng absolute value x minus 1. So this is x equals 1. So asymptote siya. So basically, nag-approach siya dito sa asymptote na ito. And may infinite discontinuity tayo since negative infinity yung value nitong part na to. So pag sinubstitute dito, negative infinity plus times negative, so positive to. Dito naman, negative infinity lang since nasa positive side naman to, so negative infinity. So notice that all our separated integrals have positive negative infinity as their limits. Makikita naman dito sa solution. Therefore, the integral is divergent. So ibig sabihin walang value since puro infinity yung mga limits niya. Okay, so let's now proceed to the last problem. Evaluate the integral from negative infinity to positive infinity. Now, 1 all over 1 plus 9x squared dx. So, pause muna ulit yung video kung gusto niyo muna i-solve on your own. Then, see the solution kung gusto niyo lang ituloy yung video. Okay, so let's see the solution. So, we split this integral since parehas may infinity. And since continuous naman siya, all throughout since x squared naman to, and wala namang points of discontinuity, we can pick any real number c. In this case, 0. And usually 0 ang pinipili kapag continuous siya in all real numbers. So 0, negative infinity ng integral from negative infinity to 0 ng itong function na to, plus from 0 to positive infinity ng function na ito, integral din. So we take the limit ulit as the approaches negative infinity, ito. And this dito naman, s naman, since iba variable. So, ngayon we use u sub, let u equals 3t, and u equals 3dt. Similarly, since parehas lang naman sila ng we can do another u sub, pero this time v yung gamit natin. Since iba, may u na tayo eh. So, sayang lang kapag gumamit ulit tayo ng u. Okay, so next, we get the integral nito is equal to limit nito. So, nasa-substitute na agad yung u na 3x, tsaka v na 3x din. So, yan, ganyan na yung magiging consequence niya. So, from t to 0, since when x equals t, u equals 3t, then when x equals s, v equals 3s. Tapos 0 lang naman din parehas kapag sinubstitute. So, hindi na magbabago yan. Okay, so we take the limit as t approaches negative infinity ng integral na to, plus yung limit as t approaches positive infinity ng integral na to. So this one is actually arctangent of u all over 3. Kasi yung 3, parang times 1/3 pala to. I almost forgot. Times 1/3 to since 3dt yung na-multiply. So times 1/3. Kaya may tangent, may arctangent over 3 ito. So from 3t to 0. Tapos dito naman from 0 to 3s since positive to. Tapos ito naman negative. So wala tong 3 dito sa part na to. So we take the limit as this approaches negative infinity ng arctangent ng 3t over 3. So 0, automatic na yan 0. And ito naman. Ganun pa rin. So, take note na ang graph nitong arctangent will always have an asymptote of pi over 2 dito sa taas. And dito, another asymptote of negative pi over 2. Okay, so yan. Tapos yung itsura ng graph niya, parang lang, ganyan na curve. Ito nag-approach lang siya, pero hindi siya natatouch ng pi over 2. Whereas dito din, sa part na to. Kaya sa negative infinity, yung limit nito is actually negative pi over 2. So pag substitute dito, negative pi over 2 over 3 is negative pi over 6. Kaya naging positive to. Dito naman, pi over 2 over 3, kaya positive 1 pi over 6. Then, ito na yung niya, yung value niya. So since naman siya, may value naman to, therefore, converge itong integral na to with the value of pi over 3. Okay, so that ends our video. Thank you for watching and see you in the next lecture video.